at all. Then two parallel lines are given, L and M. Okay. And one transverse, so suppose T is cutting to L and M, then we have to prove that the alternate interior angles are equal. First of all, in theorem 6.1, I have told you alternate interior angles are vertically opposite angles are equal. That we have discussed in theorem 6.1. How they are equal, I have told you that. So this angle is equals to this angle. Suppose this angle is x, then this is also x. And by axiom 6.4, or I have told you when chapter starting introductory part, that this angle is equals to this angle. This angle is equals to this angle. So these both are corresponding angles. So this angle is equals to this angle cause of vertically opposite angle, and this angle is equals to this angle cause of corresponding angles. Now as you can see, this is also x and this is also x. They both are equal. For suppose if I am giving name to them B, O, C, for example, and this you give D. So angle BOC equals to angle OCD equals to x. Okay. So both are alternate interior angles. See. So two lines are parallel, then alternate interior angles are equal. One thing we can understand. But this opposite also you need to understand that we call converse of this. What is the converse of this? If these both angles are equal, then lines are parallel. That also we need to keep in mind. So if this is given, then L parallel M. If L parallel M given, then this will be. Okay. So it is like related to each other, or one is the converse of other. If lines are parallel, then alternate interior angles are being made which are equal to each other. If alternate interior angles are equal, then those lines are parallel. And this is theorem 6.2 and 3. Okay, 3 is converse of this. So 6.2 if you can understand, 6.3 also you can understand. This is theorem 6.2. Okay. And the example 4 is based on theorem 6.6. What is theorem 6.6? Theorem 6.6 are if two lines are parallel to one other line, then these two are also parallel. For example, this line is parallel to this and this line is parallel to this. Means like PQ is parallel to RS and PQ is parallel to AB. Then AB is also parallel to RS. Okay. In this question, we need to find angle X and Y. This angle we need to find full angle. Okay. So what we have done the construction. What construction we have drawn line AB. So AB line we have drawn like this, that it should be parallel to PQ. And in example already given that PQ is parallel to RS. See, very simple. AB is parallel to PQ and PQ is parallel to RS. So simply what we can write from here, AB is also parallel to RS. This is theorem 6.6. Okay, now we need to find the angle XMY. XMY, this angle we need to find. So first of all, what we have PQ is parallel to AB. If PQ is parallel to AB, then I have told you two angles which are one side of transversal line, always sum is 180 degree. So angle QXM plus angle XMB equals to 180 degree. Okay, because of internal angles, because these both are internal angles of parallel lines. Okay, so angle QXM plus angle XMB is equals to 180 degree. One is 35, which is QXM. XMB we need to find, that is 180. So angle XMB is simply 135 will go that side. 180 minus 135, that will be 45. So we got 45 XMB. So here I can write 45. Now I have told you in the very last theorem, theorem 6.4, that this angle is equals to this angle because AB parallel to RS. So AB parallel to RS. So angle RYM equals to angle BMY equals to 40 degree. What I have told you, alternate interior angles. So this angle is equals to this angle. So alternate interior angle. So now this 45 and 40. This is 40 and this is 45. So add these both will go get the angle x and y. So x and y, angle x and y is equals to 40 plus 45. So we got get 85. So this x and y is 85 degree. This is the example 4. Example 5. In example 5, we have given that BE, this BE is parallel to CG. So BE is parallel to CG. This is given to us. One thing. Second thing, given that BE is bisector of this angle, means this angle equals to this angle, and CG is bisector of this angle. So BE and CG both are bisector for angle B and C. Okay, this we have to given, and we have to prove PQ is parallel to RS. This we need to prove. This is example 5. And so first of all, see, if this is X, then this also X, because bisector. And if this is Y, then this is also Y. Same bisector, because this BE is bisecting this angle and CG is bisecting this angle. Now it is given BE is parallel to CG. See, this BE is parallel to CG. I'm just putting here to make you understand, like this two lines are BE and CG. Okay. And one line is bisecting these. Means this is transversal line and this is BE and CG. So if I like this, you can understand. I'm just extending BE and CG to make you understand. Now we have this angle X and this angle Y. So X equals to Y, means this angle equals to this angle, Y corresponding angles. This angle is equals to this angle, corresponding angles. This you can understand, I think, easily. No issue in that. Okay. So X is equals to Y. Y corresponding angle. So what I can write? This angle equals to this angle. So angle ABE, angle ABE equals to angle EBQ equals to ABE equals to EBQ, which is given to us. Oh no, sorry, for I can write like more. ABE equals to BCG, corresponding angles. Corresponding angles. So simply, if this equals to this, so this is also, so this equals to also this. Means these all four angles are equals to one another. Okay. So if I'll add this full, then angle, this full is simply here X is equals to Y. Then 2X is equals to Y. That I want to tell you. X is equals to Y. Then double of X, which is 2X, means this full is equals to full of Y. So 2X is equals to 2Y. What is 2X? Angle ABQ. Angle ABQ. What is 2Y? Angle BCS. Angle BCS. So ABQ is equals to BCS. ABQ is the full part of this angle, means on line PQ, and this is on line RS. So this full angle is equals to this full angle. How it seems? It seems like corresponding angle for PQ and RS line where transversal is AD. So what I can write? By converse of corresponding angle adjoint. What is corresponding angle adjoint? Means if two angles are corresponding, then the lines are parallel. So what we can say? So we can say PQ is parallel to RS. Again, I'm making you understand full question, full example, that first of all, this is bisector, so X is equals to X. This is bisector, so Y equals to Y. Now these two are parallel lines. So this angle equals to this angle, corresponding angles. X is equals to Y. Then double of X and double of Y will also equals to 2X is equals to 2Y. What is 2X? Angle ABQ. What is 2Y? Angle BCS. this full angle equals to this full angle. These angles seems like corresponding angle, and corresponding angles are being made in which lines are in parallel line. So we can say PQ parallel to RS. This is example 5. In example 6, we need to find the value of x, y, and z. These are the x, y, and z. And what is given to us, like this line, and this line, these all are parallel to one another. Means they all are parallel. So very simple. I'm just telling in hint form. This and this both are internal angles. And sum of internal angles is 180 degree. I've told you. So y plus 55 is equals to 180 degrees. So y is equals to 180 minus 55. So y is equals to 180 minus 50, 130, and 5 more than 125. So y value is 125. See, y is equals to s. Corresponding angle. So x is equals to y equals to 125 cos of corresponding angles. I have told you corresponding angles in last example also, and you can go through exam 6.4 that you can understand more to corresponding angles. Okay, so x equals to y equals to 125 degree. So this is 125 and this is 125. Now we need to find the z. See, this is given 90 to us, so this is also 90. Y corresponding angles. So corresponding angles, this 90, this z. Okay, this is 55, then this is also 55. You can understand by linear pair also, or you can understand by alternate angles also. If this is 55. So in a triangle, we have all three angles. So sum of all angles of a triangle, 90 plus z plus 55 equals to 180 degree. Okay, sum of all three angles in a triangle is 180 degree. So 90 plus z plus 55 is equals to 180. 90 plus 55, 145 is equals to 180 degrees. So z is equals to 180 minus 145. So 80 minus 40, that will be 40, and more for high equals than 35. So we have z is equals to 35 degrees. So x and y are 125 and z is 35. This is example 6. And like this we can, this was the last example for this. So today we'll do this much only. Thank you so much for watching the video.